Alright guys, so I want to go ahead and talk to you guys a little bit about the normal curve. It's been coming up in class and I don't think I've done a good enough job explaining really what it is, right? So if we take a look here, this is a curve for a normally distributed set of data, right? And what happens here is the total area underneath this curve is equal to 1. So everything under this curve is equal to 1 or 100%. That's the area underneath the curve, right? So right here, mu is exactly in the middle, right? So if we think about mu as being exactly in the middle, that means that we have 50% over here, and we have 50% of our data over here, right? So we've got half and half, okay? Now what happens here with the normal curve is there's a few things. We talk about the spread of our data, right? And we know that the spread of our data is this idea of the standard deviation, right? So again, here's my data, right? Here's my normal curve. Here's mu in the middle, right? And what we can do is we can add a standard deviation, right? So we can be within mu plus sigma to the right. And we can also be within mu minus sigma, right, to the left. Now, interestingly enough, we know that if we go one standard deviation, just one sigma to the right, that we have 34% of our data between mu and this sigma to the right. So within one standard deviation to the right. Within one standard deviation to the left, we know that we have 34% of our data, right? So that area is 0.34, 0.34. Altogether, if you're within one standard deviation, right, you are within 68% of your data, okay, is captured by that, right? Now, if we go to 2 standard deviations, the number goes up pretty high, right? And I'm not sure exactly off the top of my head, but if we go to 2 standard deviations, right? So here's mu, here's our normal curve, right? We're going to go 1 sigma, and then we're going to go a second sigma, all right? So 1 sigma, then a second sigma, okay? And then we go to the left and we go 1 sigma and then a second sigma. So this will be mu minus 2 sigma, and this here will be mu plus 2 sigma. And what that means is this part of my curve, how much of my data is captured here? Well, it's 95% of my data, right? So what that means here is that this is 2.5%. If I go beyond my 2 sigma, right? If I go beyond my 2 sigma to the right, it's also 2.5% because 95% of my data is here in the middle, right? Same thing here, right, with my 34%, right? That means that over here is 16% and over here is 16%, right? So this is just kind of a breakdown of what our data looks like, okay? Now what we've been talking about in class are z-scores and percentiles. So z-scores and percentiles. A z-score is really just how many standard deviations am I to the left or the right of my data, right? So again, if I take a look here, right? Again, here's my mu, right? Let's say z is equal to 1.34, right? Just a random number, right? But we know that here is mu, right? And then we know that here is, 1 standard deviation. Well, 1.34 is right here. So here's z equals 1.34. And then what we've been doing is we've been going to our tables. And we go to our tables, we get some percent, right? So we look up z equals 1.3, right? And we go over to where it's 0.04, and we look over and we look down, and there's a number here, okay? So here, 1.3, we go over, 0.04, we go down, and we look at the number, and that represents 1.34, right? Well, what does this number actually represent? Well, what it represents is the area underneath the curve to the left. So that means all of this space is what that percentile is. So remember, if this curve is 100, right, or one whole number, this shaded area is the percent to the left. So a percentile is just the percent to the left, okay? So on our homework, we had some questions where we had to go ahead and find out things like, well, what's the percent between the mean and 1.34, right? So here, if we think about that problem, right, we've got the mean right here. We've got 1.34 out here, right? Z equals 1.34. So this is mu plus 1.34 standard deviations, right? Well, if I want the area in between, right, I can use my table. And when I use my table, I can find this big area. And then I know this part here to the left of mu is 50%. So whatever number I look up here, I simply turn it into a percent, subtract the 50% I'm taking away, and this tells me the area between mu, right, and z, right? Now, if I want the area between two z-scores, right, conceptually the same thing's going to happen, right? Two z-scores, right? So maybe I've got z equals negative, I don't know, 0.6, and then I've got z equals 2.1, right? So if I want the area between these two, right, what I could think about this as is finding the area of z equals 2.1, right? So I can do the area to the right of 2.1. I can find this whole area, right, for z equals 2.1, and I can subtract this area for z equals negative 0.6, right? And if I take this whole curve and I subtract that part, I'll be left with this portion, right? So I just want to make sure conceptually you guys kind of understand what I'm talking about when I'm talking about these z-scores and the percentiles and all these other things, because I think it's getting a little bit tricky, all right? We'll talk a little bit more about confidence intervals when I see you guys in class again on Friday. Thanks.